Okay, so the other day I posted a video about unit vectors and how we can use that to define damage types, and then another video talking about how we can interpolate to get new damage types, but I have a theory. I know, a theory about magic from the Gorilla Desi? Who'd have known? So, the idea is if in this vector space, for whatever reason, we'll have heat and movement for demonstration, but there's actually going to be a lot of these, we have all the damage types all defined. Why are they where they are? So here we have fire, and that's well defined, and here we have lightning, and that's well defined, and a fun idea I've had is that we can move between these and get a new damage type, but why don't wizards do this all the time? Well, so in the theory of magic, we talked about how each damage type has this linear relationship between the level and the average damage. The relationship might be a bit more complex, but at least for this is going to be fine. All that really matters is that we have some relationship. And in this interpolation video, I posit that it is the same as we move between each other. I don't know if that's true. What if there are only certain regions in this space that have a really strong damage type level correlation? So if I have this graph here, here's level, there's damage. If we're at one of these points, we have a strong gradient. That's key. So that's what we see here, a nice straight line. But what if it's modified by this thing here? That's kind of a Gaussian. Basically what it says is, as this factor k moves away from m, which might be our space in the vector space where the damage type is defined, the gradient will go down. So if I move k away from m, we can see that quickly this relationship collapses. And maybe that's what happens if we're not in one of the predefined damage types of, 5e D&D. So here we have a good damage type, here we have a good damage type, and maybe between here we have increasingly weaker and weaker damage relationships until about here where it starts increasing again for lightning. It also might be more complex than this straight line example I'm showing. Maybe, for example, instead of keeping it as a straight line, the further you move from one of these, the more it becomes something like a logarithmic curve, where it's sort of you need to put in exponentially more energy to get the same doubling effect. Oh, I need to work on this vector system. I need to get the basics foundation done before I do the rest of this. This is so exciting.